Hello, how are you? I have question 15. It's a simple question, that's why I'm gonna do 15 and 16 in the same video. So the question says the unit of capacitance is equivalent to, of course the unit of capacitance is farad, right? Is it equal to second to the power minus 1 or second or volt over meter or coulomb over volt? Let's remember the formula of capacitance, C equal Q over V, which is the potential difference. So here the unit is farad equals the unit of charge is coulomb and the unit of potential difference is volt. Okay, so it's very simple. The answer is C over V. Okay, or maybe you can see it C V minus 1. Okay, so the answer is D. Okay, now we go to question 16. Question 16 says 4 identical capacitors are connected in the opposite circuit. If the potential difference of the battery is 10 volts, then the potential difference in capacitor C2 is, I need the voltage in here, I'll call it V2, which is basically the same voltage in the parallel combination. This is a property of the parallel because the V2 here and V3 here and V4 are all equal to the V parallel, okay? Notice that the parallel combination here is connected in series with C1, which means that the voltage of the battery will be split in two parts, V1 plus Vp, which is basically the same as V1 plus V2. Okay, so in order to find V2, I need to find V1, and I already have V, which is 10. Okay. So I need here the V1 here. Remember that the charge in the circuit here, the total charge, equal the charge in the C1. Why? Because the C1 is connected in series with the battery, right? So I can say that Q total is equal to Q1, okay? Q total, I can write it as C total multiplied total voltage. And here Q1 equals to C1, which is basically, C1, okay, multiple V1. Okay, guys? Remember that they told me there are 3 identical capacitors. So each one of them is C. I will name it C. Okay, so first let's find the C total. So C total is going to be, of course, in the parallel combination, since all of them are connected in parallel, so the total of them is going to be 3C. Okay, now this 3C and this C are connected in series. So it's going to be 1 over C plus 1 over 3C. I hope you can do this. Remember, in order to add 2 fractions, I need to have the same denominator, right? So in here, I will multiply up and down by 3. So I multiply here 3 and here 3. So it's going to be down here 3C and up will be 4 to the power minus 1. So when I flip, it's going to be, okay, this will give me that C total equals 3C over 4. Okay, let's substitute this in the equation I wrote before, which is here. Okay, so instead of C total, I will put 3C over 4. Okay, multiplied by V equals, we agreed that C1 is C, okay, multiple V1. Now I can cut this C with this C. I will have now V1 alone, okay, V1 equals to 3 over 4 V. Okay, I will complete right here. So V1 equals 3 over 4 multiple 10. This will give me 7.5. Now I go back to this equation and I write V is 10 equals to V1, I just found it, 7.5 plus V2, okay? And that makes the V2 equals 10 minus 7.5, it's 2.5 volts. So the answer is B, okay? Always remember, guys, the properties of series and parallel connection. It will be a great help in solving such problems. If you have any question, please leave it in the comments below. See you.